Okay, welcome back to the course. In the previous lecture we have talked about the libraries that we are going to use, and now we have to use it. First I would like to add as dev some types for TypeScripts, like the types of hasha that we are going to use, and even from for the library that we was going to see, because as you see here we was going having an error. I'd like to remove this error using the library provided from the types of the TypeScript, and now the error is go away. And now we have to install the library as well, like, okay, not in dev, but we are going to use actually hasha. And we are going to use even the amp and generator library to generate random words. Since the last library that I am installing is a JavaScript library, and then I would like to interact with TypeScript, I have to also to install the nodes TypeScript on our application. Otherwise TypeScript will be not able to recognize what we are writing inside to our TypeScript file that is a JavaScript part. Doing that, we are add minus dev the types of node. Minus dev, sorry. Okay, now I'm looking if everything is okay, is correct. I have hasha, node, readline sync this time, and here you hasha and generator, readline, everything. Okay, that means that actually I have everything to build our application, or to build our functions that will going to generate our private key. We create a new file, call it is like crypto TypeScript. Okay, now I'm going to use as a variable generator required by the generator. Then I'm going to use to import hasha from hasha. Yeah, actually that's it. Now I think that we can wrap a function. I call this function our SHA-266 function. This is taking a word as an argument, that is a string, and provide us back the string as well, but this time the string is the representation on SHA-256 of the word that we are giving. Return using the library hasha the word, we are taking the word, and we have to provide also some options such as the algorithm that we are going to use for doing our hash, and also the type of the encoding that we are going to use, and then we are going to use the hash, the hex. Okay, this is like a help function to have the code more and more clear. Now I am creating this function to encrypt our private key, and is totally based my opinion, is just a function. It could be whatever you want, but I like to generate in this way to keep the things easy to understand and very useful as well. I may generate mnemonic, I'll say mnemonic private key, and this is the function that I am going to create, and this function is giving me back a string. Let's say I can create a constant that is my mnemonic that will be like a string, an array of strings, and here I'm going to use the library that will generate a list of, let's say, 4 words. Okay, this is going to generate like random 4 words like home, food, go, and let's say pen. Okay, this is what is going to do this library right now. Now that I have this, I can like console log and say to the user that the user must store those information in some place and keep them in a very safe environment, because they are needs if he needs to restore the private keys. Let's say write down those mnemonic words that are used to generate your private key. Okay, and then I can also say what they are. Okay, it's like the mnemonic. Okay, this is done. Now I have actually an array of strings, and now I can start to work and interact with those words. I can create like an array of hashes that are giving them array of strings and keep like empty at the moment. Now I can use my mnemonic, do a map function. Inside to that I can use like each word, and from then what I can do inside is add that word, the function, like hashes, push inside to my empty array, using my head function that we was going to use before, and provide the word, right? That way I have populated my hashes with the representation of the SHA-256 of each word that are generated from the mnemonic function generator, right? Now that I have those 4 words, I can combine them again in order to have at the end just one single SHA-256 representation of my private key. Let's say I can use like a temp result, that is the temp results 1, and let's say to keep the things very simple, I can make a SHA-256 of the SHA-256 again of the hashes 0 plus the SHA-256 again of the hashes 1. Okay, and then I can do the same things again with the other two, 1, 2, and 3, and at the end I can combine and generate my final result. Let's say this is called the private key. It is like taken from this. Yeah. Plus taken from this, right? Okay, actually I'm thinking, and yeah, I forgot to make the SHA 566, how it goes, yeah. And now I have my private key, result, return the private key. What I was doing here actually is like a small Merkle tree of the random generated mnemonic generated words from this library, and just with these simple steps I am generating a very strong password, but I will be able to generate every time that I need if I will keep safe the 4 words that are generated from my system. I can export this function of my crypto TypeScript file because I'm going to use this function when I have to generate my wallet. For now I will close here and we will make a quick pause and we will see how we can use this function inside to our wallet in the next lecture. See you.